So what is the shape, center, and spread of the sampling distribution of the sample proportion p hat? Well, I guess first of all, what is the sampling distribution of the sample proportion? Imagine a population with parameter p. The p stands for population proportion. That means that certain proportion of individuals in this population have specific characteristic. For example, 29% of American adults do not own a credit card. Or 3% of K-12 students are homeschooled. So these are the examples of population proportion. Then if we obtain simple random samples of the same size from that population, then for each sample we can obtain sample proportion. And sample proportions will vary from sample to sample. They won't be the same. So for example, one sample is going to have only 1% of K-12 students that are homeschooled. And another sample can have 6% of K-12 students in that sample that are homeschooled, right? So sample proportions will vary from sample to sample, and that's what makes a sampling distribution of proportions. So we want to learn its behavior. So if we look at all those samples and their sample proportions, what's the behavior of those numbers? Well, it's described here. That distribution can be, as any distribution can be described in terms of its shape. We can describe its center and the spread. So we know that the shape of the sampling distribution of the sample proportion is approximately normal if those two conditions are satisfied. So condition number one is that sample size has to be no more than 5% of the population size. So sample size is less than or equal to 5% of the population size. It means that sample size should be relatively small. And here's the second condition. If we take sample size, multiply by the population proportion, and then multiply by 1 minus population proportion, keep in mind that population proportion should be expressed in terms of decimals here. So if it's given in terms of percentage, originally it has to be converted to decimal. So that product should be greater than or equal to 10. So if those two conditions are satisfied, then we know that the sampling distribution is approximately normal. And that means that we can use either z-table or calculator to answer questions about specific sample proportions. Now, center is going to be measured using the mean, and it's going to be easy to find because the mean of the sampling distribution of sample proportion, and that's the notation we're going to use, mean of the sampling distribution of sample proportion, is going to be exactly the same as population proportion. In other words, if we look at all sample proportions, if we take them all and find their average, we're going to find that the average of sample proportions, which is the mean, is going to be the same as population proportion. And then finally the spread, we measure using standard deviation, right? So the standard deviation of the sampling distribution of p hat is, that's the notation, sigma p hat, is going to be found by using this formula. So it's square root of, here we have p, which is population proportion, times 1 minus p, divided by sample size. So n, sample size, this is all inside the square root. So let's use what we just talked about to answer the following questions. So in this example, it says that Bureau of Labor Statistics reported in the recent year that 5% of employed adults in the United States held multiple jobs. A random sample of 75 employed adults is chosen. So this sentence here, 5% of employed adults in the United States held multiple jobs, describes population proportion. So population, in this example, all employed adults in the United States. And we know that 5% of them held multiple jobs. So that represents population proportion. Which we denote, population proportion, which we denote by P, and we describe it using decimal instead of percentage. So 5%, I convert to decimal, it becomes 0.05. Okay, so what's the question? Now, one more time, a random sample of 75 employed adults is chosen. And the question is it appropriate to use the normal approximation to find the probability that less than 6.5% of the individuals in the sample hold multiple jobs? Right? So we obtain some sample of 75 employed adults, and the question is, what's the chance that in that sample, less than 6.5% of the individuals hold multiple jobs? But is it appropriate to use the normal approximation or normal distribution to answer that question? Let's think. So we know that distribution of the sample proportion is going to have approximately normal shape if there are two conditions. If the sample size is less than 5% of the population size, that's one. And second, if this condition is satisfied. So when we look at the sample size, so n equals 75, right? The first example. Is it less than 5% of population size? We don't have information about the size of the population, but we can just make a rough estimate without even naming any numbers. So if population here is all employed adults in the United States, we know that these are millions of people, right? So definitely 75 individuals or 75 adults is less than 5% of the population. So that's less than or equal to 5% of the population. So that condition is satisfied. However, the second condition is the following. So that's condition number one, that's condition number two. So the following inequality must be satisfied. So n times p times 1 minus p should be greater than or equal to 10. Let's check that. So n is the sample size, that's 75, times p, that's population proportion, that's 0.05. If we multiply that by 1 minus 0.05, is it going to be greater than or equal to 10? So let's see what it equals to. That's 3.7. And that's not greater than or equal to 10, right? So that means that this condition is not satisfied. This means that we cannot say that the sampling distribution of the sample proportion in the case when sample size is 75 has approximately normal shape. And because we cannot say that, well, we're not able to answer the question. We can't really find probability because we don't know what shape of that distribution is. So then the answer to the question is going to be no, it is not appropriate to use the normal approximation to find the probability. So here it is. That's the answer. Let's try question B. Here it says that a new sample of 350 employed adults is chosen. And find, same kind of probability. Find the probability that less than 6.5% of the individuals in that sample hold multiple jobs. Let's check if we can use normal approximation in this case. So step one, check if normal approximation can be used. So for that we have to confirm that sample size is less than or equal to 5% of the population. And again, we're going to use just the common sense here that definitely 350 adults, employed adults, is less than 5% of the entire population of employed adults in the United States, since these are tens of millions. So I'll just simply say that n is less than or equal to 0.05 n. So that's satisfied. And then the second one we have to calculate. So we need to calculate if n times p times 1 minus p is greater than or equal to 10. Let's plug in the numbers. N is sample size, right? 350. P is population proportion, and it's 0.05. We're still working with that same population. And then times 1 minus 0.05. that equals 16.6, which is greater than or equal to 10, right? That's greater than or equal to 10. It means that second condition is also satisfied, and now we can say yes, it is appropriate to use normal approximation to answer that question, and which is we can use either z-table and do it by hand, or we can use normal CDF function on the calculator. That's how we'll do it. But to use either one of those, we have to know the mean of the distribution and the standard deviation of the distribution, right? So step 2 will be to find mean and the standard deviation. Well, to find mean for the sampling distribution of the sample proportion, and it's denoted by mu p hat, we simply have to set it equal to population proportion. So it's always going to be the same as the population proportion, which is 0.05. And then to find standard deviation of that distribution, sigma p hat, we have to use a little formula, and it goes like this. It's square root of p, which is population proportion, times 1 minus p, divided by n, that's the sample size. So square root of 0.05 times 1 minus 0.05 divided by sample size is 350, right? So that's n, 350. I will enter this all as one expression on the calculator. So let me show you how I am entering it. So I'm starting with the square root, second, x squared to give me square root, and then inside I'm typing 0.05, parenthesis 1 minus 0.05, and then divide by 350. So that all should be inside the square root. Enter. And I got 0.012. Let's round to 3 decimal places. 0.012. So now, once we described that distribution, we described its center, and we described its spread by calculating standard deviation, now we can answer the question. So step 3, we're going to answer the question itself. So we're going to find the probability that in that sample, less than 6.5% of the individuals hold multiple jobs, right? So it means that 6.5 represents proportion, that's sample proportion. So we're going to find probability that sample proportion, p hat, is less than, well, it's 6.5%, but when we use p or p hat, we convert that percentage to decimal. P hat is less than 0.065. That's how I can write it down. So as I said, I will be using calculator to calculate that probability, and that's normal CDF function. So I have to press second, vars, normal CDF, it's line number 2. Remember, for this function, to use this function, we need to describe the lower boundary and the upper boundary of the region on the normal curve, as well as the mean and standard deviation. Those two we just found in step 2. Let me sketch. I have a little bit of space here. Let me sketch that normal curve so that I can figure out the boundaries. Okay, so let's say that's the normal curve. Its center is at 0.05, right? And we're trying to find probability that sample proportion is less than 0.065. So 0.065 is somewhere over here. Less than, it means that I have to look at everything that's to the left. So I'm highlighting area on the normal curve that's to the left of 0.065, and the area right here represents both proportion and probability. Well, we need to find probability, so this area represents probability. To find this area on the calculator, I'll use normal CDF, and the numbers that I'm entering, the lower boundary. So for this region, the lower boundary, which is always on the left hand side, it's not given, so I just need to choose very small numbers. So I'll use negative 99999. And then the upper boundary is 0.605, is 0.065, 0.065. Now mean is right here from step 2, 0.05. That's the same as population proportion, and standard deviation we calculated using the formula, and that is 0.012. So 0.05, comma 0.012. Pressing enter a few times, and that's the answer I'm getting. 0.894. Let me just put it over here. That's 0.894, which is approximately 89%. So what is 89% chance? So that's the chance that in the random sample of 350 employed adults, less than 6.5% of them will have multiple jobs. So that's the meaning. Or I can say also this way, I can interpret this way. If I randomly obtain 1,000 simple random samples of size 350, so I have 1,000 samples, then I can expect that in 894 of them, or in about 894 of them, proportion of adults that have multiple jobs is going to be less than 6.5%. So that's another interpretation. We have a few more questions that we have to answer, but now we're going to go a little bit quicker of them because they all about that same sample size, 350 individuals in a sample. That means that we're going to be using same information that we just found about that distribution, right? So I'm going to copy that to this page. So we're going to use the fact that mean of the distribution, of the sampling distribution, is 0.05, and then standard deviation of the sampling distribution of the proportion is 0.012. So let's read the question. In this question, we need to find the probability that more than 6% of the individuals in the sample of 350 hold multiple jobs. So that's how I can write the question in short. I need to find probability that more than 6%. A probability that sample proportion of individuals with multiple jobs is more than 6%. That's same as 0.06. If I sketch a normal curve, this is how it's going to look like. So mean is 0.05. Sample proportion that's used here is 0.06. And probability that more than 6% of individuals will have multiple jobs corresponds to the area under the normal curve to the right of 0.06 because of the greater sign, because of the word more, right? Because of that keyword more. So I need to find this area, and that's going to be same as probability. So I will be using normal CDF. And number that we'll have to enter, the lower boundary of this region is at 0.06. The upper boundary is not given. Well, there is no upper boundary. That means that I'm using some very large number. I'll use just 5 nines right here, 99,000. Mean is 0.05. Standard deviation is 0.012. Let's see what it is. So second bars, normal CDF. 0.06 for the lower boundary, 99999 for the upper boundary, same mean, same standard deviation as in our last example, so I'm pressing enter a few times, and that's the probability that we get. 0.202, that's approximately 20% chance. So probability that more than 6% of the individuals in the sample of 300 hold multiple jobs is 20%. Or if I create or if I obtain 1,000 simple random samples of size 350, then I can expect that about 202 of them will have more than 6% of individuals with multiple jobs. D. Find the probability that the proportion of individuals on the sample, P hat, who hold multiple jobs is between 0.05 and 0.10. So that's what we want to find. Right? Now on the normal curve, that's going to look like that. Mean is 0.05. That's the mean. But here we want to find probability that sample proportion is between those numbers. Okay, 0.05 is here already. And then 0.10 is, let's say, right here. So that probability corresponds to the area on the normal curve that's in between 0.05 and 0.10. So we'll use normal CDF function with the following numbers used. So the lower boundary of this region is at 0.05. The upper boundary is at 0.10. Mean is 0.05, and then 0.012 is the standard deviation, right? Let's see. Second verse, normal CDF, 0.05, the lower boundary, 0.10, upper boundary. Everything else stays the same. I'm pressing enter, and I'm getting 0.50, right? Or 0.5. So that's approximately 50%. So it's a 50% chance that proportion of individuals in the sample of 350 would hold multiple jobs is between 0.05 and 0.10. So between 5% and 10%. And then finally, the last question is, would it be unusual if less than 4% of the individuals in the sample of 300 held multiple jobs? So let's say we obtained simple random sample of 350 individuals, and we found that less than 4% of them hold multiple jobs. Is this unusual? Remember, unusual means that chance of that happening should be less than 5%. Less than 5% chance. Well, let's find what's the chance of getting a sample like that. Let's find probability that the proportion of individuals in a sample that hold multiple jobs is less than 4%, so less than 0.04. This is how I'm going to show this on the normal curve. Mean is 0.05. Now 0.04 is over here to the left. The fact that we need to find probability that the proportion is less than 0.04 indicates that I need to find area that's to the left of 0.04. So that area represents probability. We'll use normal CDF function. The lower boundary of this region does not exist, but we'll just use very small number instead, -99999. And the upper boundary of this region is 0.04. Mean is 0.05. Standard deviation is 0.012. So let's see what we'll get. -9999. By the way, don't forget that when you use negative numbers on this calculator, you have to press this button for a negative sign. Don't use subtraction. Otherwise, your calculator is not going to like that. So -9999. The upper boundary 0.04. And that's what we got. 0.202. And that's approximately 20%, right? So it's 20% chance that if you randomly select a sample of 300 individuals, employed individuals, then less than 4% of them are going to have multiple jobs. So 20% chance. Does this mean that it's an unusual event? Well, no, it's far from being unusual. It would be unusual if probability would be less than 5%, right? So this is more than 5% chance. So that means that we conclude that it's not unusual. It's not unusual. That's how you answer this question.